Our final video for this module covers data transformation and date-time data using the emissions CSV. As always, we're going to start by loading our packages. We start with Tidyverse, and as you can see, when you load Tidyverse, you also get access to the core Tidyverse packages, so Forcats, dplyr, lubridate, and so on. And as always, we also use the here package to tell our computer where the root directory is. Of course, mine is my DAX 601R project. We'll read in the emissions CSV, and let's look and get a sense of what's in this data set. I like to start with head because it gives me the the data type. So we have doubles, characters, and so on. And then I also pop this open in the view panel. So let's make that a little easier for you to see. So here we have a year column, which we know is a double. We have company names and company types, commodity types, so this is mostly about oil and natural gas. We have two double columns, so we have production value and total emissions, and then in the middle we have a character column that gives us production units. So our first question is always, is it tidy? And it looks like perhaps there's just one parent entity or one parent type, and for now, it looks like there's only two commodity types. So in that case, maybe we want to pivot this wider if oil and natural gas are important enough on their own. But there are 12,000 observations, and we don't want to scroll through everything manually, so that's where we use Summarize. I always like to check if there are more level values than I thought. So we're going to use Summarize across those three columns and end distinct. And what we can see is actually commodity has 9 levels, production unit has 4, and parent entity has 122. So it won't make sense to pivot those columns wider. And if we did, and here's an example here, we'll see that there's a lot of NA values. So it does reduce the number of rows, but now there's tons of missing data in our columns. So in this data set, the original data set, and we'll get rid of emissions wide here, it seems like everything is tidy. We have year, parent entity refers to a single variable, so just the company names. Parent type, we know that there are 3 different types now, so it makes sense to have those in a single column, and so on. And what that means about the unit of observation is that it's an individual company in an individual year with an individual commodity, is what each row represents. And that's what I want you to think about for each of your data sets. For your unit of analysis, what is a unique case, and what are the combination of values that make it unique? We can use mutate to calculate new values based on those numeric columns. So for example, production emissions can be equivalent to production value times total emissions in those 2 columns. We can square it. We can add 1. We can create new columns based on existing ones. So here we can see that we have a calculation. And we've added in all of these columns based on the original ones. And with this, we can calculate things like which company type, and there are 3, investor-owned company, nation-state, or state-owned entity, has the highest total emissions across companies and commodity types. So essentially, we want to collapse everything into just that company type. Here's how we can do that. We're going to create a new data frame just so I can show you what we're doing. We can group by parent type, which is the company type variable that we're interested in. And then we're going to use Summarize to take the sum of total emissions across all of the rows within the parent type group. And then, of course, we'll arrange in descending order. And here we go. We're able to collapse this data into the following result, where we see that the nation-states owned companies have the most total emission across time in our data. And I use this example because I want to point out the importance of using sum when we're dealing with aggregates. So what happens if we write the exact same equation, but we don't use sum? So here, total emissions is just total emissions for each row. What you'll see is that group by is ignored. The reason is that we haven't given R a way to aggregate within Summarize. So what we're telling R here is that we want it to group by column 1, which is parent type, and then we want to calculate total emissions using column 2, which for us is total emissions. But we've given it a function that knows to take in a vector of values and return a single one. Here, we haven't given R a way to aggregate across the rows in each group. So it ignores the grouping and just prints out each row. And this will be helpful as you work through the Australian data. We can also recode our variables into categories using if-else and case-when. So if-else is a new function, and we'll cover it additionally in a few weeks. But essentially what it does is it says if a value is equivalent to this, then we are going to assign it to this value. If it is not equivalent to this, we'll assign it to the other one. So it's a binary. Here what we're saying is we're creating a new variable called production value greater than 100. If production value is greater than 100, so you always have to start with the column name and then a logical operator and a value. If it is greater than 100, then we want production value greater than 100 to read greater than 100. Else, and else meaning if production value is not greater than 100, then we label it as less than or equal to 100. And the same logic here. If total emissions is greater than 100, we label total emissions large as large. Else, it is small. And you've seen case-when in your tutorials, but just a reminder, this is to handle more complex cases than a yes or no or a large or small sort of value. So when year is less than 1900, century is going to be called 19th. When year is greater than or equal to 1900 and year is less than 2000, we're going to label century as 20th. And when it's greater than or equal to 2000, we will label century as 21st. And then we're relocating century to be right after year. So we've done a lot. We've created 3 new variables based on our existing data with just this single line of pipes. And let's check out emissions now. First, we have century right after the year column. So we see 20th, 21st, and so on. And then we also have our production value and total emissions binary variables. So less than or equal to 100 and small, and we can see here some examples of greater than 100 or large. And so what we've done is we've broken down a ton of numbers into smaller categories that we can work with. You could also turn these into factors if you wanted to. And what we can do with the century column is that we can use that to calculate total emissions across the century. So this is very similar to the logic that we used up here with parent type. What we want is to group by century, use Summarize, create a new column called total emissions. And again, the new column is only within the Summarize data frame. We're not actually editing emissions. And we're giving it a way to aggregate using sum. Other aggregate functions that we've used before include mean and ndistinct. So here we can see that the total emissions have gone up a lot across the centuries. It was only at 172 in the 19th century. Now in the 21st, we are at 734,000 plus. We can also use the year column to calculate emissions across the decades. Now this doesn't use LubriDate because we already have a nice year column to work with, but I'm just giving you an example of what you can do with year. We're going to use the modular arithmetic function to create a decade column. We're going to group by that decade column, and then again we're going to summarize. This time we're using mean as our aggregate function. And there we can see in descending order, here we have 2020 at 153 average emissions, and then the lowest is 1850 at 0.0566. So here I've given you examples for how to use mutate, how to use if-else, and how to handle aggregate values across groups.